Hello, Fruitport High School AP Chem students. So, a quick little lesson. This is your lesson for at home here at, kind of around the September 22nd or 24th, depending on your blue group or white group. But today we're going to talk about percent mass. And now, when we talk about percent mass, it comes up periodically throughout the course. And it's always good to remember. So, percent mass is a percentage based on weight, right? Based on mass. So to find the percent mass, we always do the simple formula. You'll take the mass of part of a substance divided by the total mass. Okay? And because it's percent, we have to do that, move the decimal or multiply by 100 in there. Okay? So the part divided by the total. Just like if you want to find what percent you earned on a test, you take the part of the test you got right divided by the total points possible. But here we're doing the mass of a part divided by total mass. So you'll see percent mass used in things like, hey, a watermelon is 97% water. That means the weight of a watermelon is 97% comes from H2O. Body fat percent, that is based not on counting particles, but on mass. So if you have 25% body fat, that means that this weight comes from body fat, right? So that percentage. So if you have two masses, it's very easy. You just take the mass of one part, divide it by the mass of the other part. How will this work in class? Well, this can come up in lab data. We did this with the penny lab. What was the mass of just the copper part of the penny? And we divided it by the total mass of the penny. So we're doing grams divided by grams, and we got a percent. For your homework this week, you'll have some that talk about elements. Maybe you'll be given a molecule like, how about a nitrate molecule? I know that's not a molecule. A polyatomic ion, NO3 with a -1. And if they want to know what's the percent of the oxygen in nitrate. And so to do this, you'll take the mass of the oxygen part divided by the mass of the whole nitrate. Now, when we do these numbers here, we can get mass not in grams, we can actually get mass from the periodic table. So the top number here would be the mass of oxygen. And don't forget there's 3 of them. So it's going to be 16 times 3 on the top. Or you can take 16 plus 16 plus 16. And the bottom number is going to be the mass of the nitrogen plus the mass of the 3 oxygens. So we'll have the 16 times 3, but also the 14 for the nitrogen. I got those numbers from the periodic table. So I don't have a calculator handy, so I'll use my phone. And so 16 times 3 is 48. So my top number is going to end up being 48. That's just the mass of the oxygen part, and I'll divide it, the total mass of nitrate is 62. That's 14 plus 16 plus 16 plus 16. And if I take 48 divided by 62, I get an answer of 0.77, which is 77%. Now, in this case here, don't pay too much attention to significant figures and so on. So 77% is the mass of the oxygen. That's the percent oxygen in nitrate. How would I find the percent nitrogen? Well, I could start over with my original formula, and I could, instead of putting the oxygen on the part, here's my original formula, I could put the nitrogen on the top. And so I could put 14 on the top, and I would still have 62 on the bottom. Or you might know a trick. If there's only 2 components, nitrogen and oxygen, the 2 percentages have to add up to 100%. So you can find the difference between this percent and 100%. My brain tells me that's 23% without thinking too much about it. Okay? So let me slide the camera over a little bit and do one more problem. And this is what we're going to do in lab, maybe next time we see you. Right? Sometimes we'll come across a chemical like this. We got manganese sulfate that is septohydrate. So sometimes we'll have a chemical that has waters as part of the structure here. And so when we have one manganese, one sulfate, and 7 waters, it can make this big giant crystal. And we use this dot with the 7 instead of using parentheses. You might prefer it to be a water with a 7. But when we have a hydrate, we use this method instead. So if we wanted to know the percent water by mass, right, we would put the mass of 7 waters on the top. And what goes on the bottom? The mass of everything. So you would get the mass of Mn and S, 4 O's, and 7 waters on the bottom. Now, if we do this in the lab, you'll actually get grams and measurements and scales with mass. And but if we know the formula, we can use the periodic table. And so 7, I know the molar mass of water is 18, so 7 times 18, whatever that calculates, would be the top number. And the bottom number will have Mn, which looks like it's a weight of 55. And then sulfur is 32. Oxygen is 16, but there's 4 of them. And we have the weight of water, and there's 7 of them. So that's a lot of numbers to add up. But whatever this total number is, this would be the bottom number. I'll let you calculate it. The last trick that will come up on your homework and throughout this year is sometimes you'll ask for this number, and you'll have information for these 2 starting parts. Sometimes you'll know the percent mass and you'll know the total mass, and they'll ask you, well, what mass comes from this? If I weigh 210 pounds and my body fat percent is 24%, how much fat is actually on my body? So if we know the percent, we know the total, we can calculate the mass of just the part using our algebra skills, and that might come up in a homework assignment too. So I hope this video helps. I'll also try to find maybe a YouTube video that has this redone, and there'll be some homework problems for you and CAPA problems for you. So good luck on your at-home lesson today.